Hello, in this lesson 3.3 proportions, we're going to take a look at the beginnings of proportions and what they are and how they work and how we can see if proportions are equal or not. Before we get into the workbook, I'd like to take a look at some visuals that can help us understand proportions. If we look at the first visual on the left, it's all about the ride tickets at a fair. So one ride costs you 4 tickets. 2 rides costs 8 tickets, 3 costs 12 tickets, and 4 rides costs 16 tickets. So it doesn't matter here how many rides you go on. Each and every ride is going to be the same, proportionately. So you're going to pay 4 tickets per ride, no matter how many rides you go on. So we can say that one ride is to 4 tickets, and that's equal to 2 rides is to 8 tickets. And that's equal to 3 over 12 and 4 over 16. So we know that proportionately you're going to be paying the same no matter how many rides you go on. Sometimes we use this when we talk about money for something like these potatoes. 1 pound costs $1.19. and 2 pounds cost $2.38. If we want to know that we're paying the same rate, we can use a calculator to determine that. So if we take $2.38 and we divide by 2, we see that indeed we're paying the same price. We're buying 2 pounds, but it's costing us $1.19 per pound. And we can try with the 3 pounds to see if that's also the same price. $3.57 divided by 3 does equal $1.19. So relative, it doesn't matter how many pounds of potatoes we're buying, we're paying the same per pound. Now we know in life sometimes that's not the case. Sometimes when you buy more of something, you get it for a little bit cheaper. And what you have there is an improportionate relationship. So we're going to take a look at proportionate relationships today. Proportions are used in many different ways. If you take a look at the image on the left, this is a drawing of a standard person, if you will. And what this artist has done is they've taken the size of the head and they've determined that if they stack about 8 heads, that creates a body size and height that they can create proportionately. But if they want to make the person shorter, then what they do is they decrease the number of heads or the height of the person, but still the body size is proportionate. So even though one is taller and one is shorter, proportionately their bodies look very similar. Another way we can use proportions in math is to compare things like similar triangles. These triangles have the same shape, but they're different sizes. But the question for us is, how do we find out if they have the same proportions? Meaning, is it possible for us to determine that their bases are proportionate, that their heights are proportionate, that their diagonals are proportionate? Anytime we take an image on a photocopier or on a computer, and we blow it up from smaller to bigger, we are creating a larger size of it, but proportionately we're keeping it the same. So that's something that can help us to understand how proportions work. So in this lesson, we're going to write proportions, and we're going to determine if proportions that are shown to us are true or false. And the method most commonly used for that is to find cross products. Sometimes we set up proportions as ratios, where we don't need to have the units, but sometimes we have proportions that are rates. So if we have a rate, that means that the units don't match, and so we should always show those units in our proportion. So if we look at the first example here, we have $1 over 2 candies, so $1 is to 2 candies, as $3 is to 6 candies. Notice that the top or numerator position, if you will, is all about the money, and the bottom or denominator position is about the candies. Proportions are always set up this way. The units always must match. So if you're going to have dollars in the top of your proportion, it has to be consistent on both sides of the equal sign. And the same thing goes with the candies. The units in the proportions must match. And that is going to be very, very helpful for us later when we're going to solve proportions. So a proportion is really just a way for us to show that ratios or rates are equal. It doesn't mean they're the same size. If you remember the picture of the two triangles, for example, one was big and one was small, but proportionately they were equal. So if we think back to how ratios work, they're very similar to fractions. 15 over 10 is 15 is to 10, as 3 is to 2. Well, these two are equal because if we divide 15 divided by 5 and 10 divided by 5, we get 3 over 2. So we have a proportion here. Equivalent fractions are proportionate fractions. So we've done many of those in the past. So proportion is really just a way for us to show equality. So we know that 6 eggs out of 12 eggs is the same as half a dozen. So we can say 6 is to 12 as 1 is to 2. And when we say that, we are forming a proportion. There are two methods to figure out if a proportion is true or false. The first method is to write these fractions in lowest terms to determine if they're equivalent. So is 3/5 equal to 6/10? 3/5 is already in lowest terms, so we can reduce 6/10 to lowest terms. And when we do that, we do get 3/5. So we know that this is a true proportion. If we take a look at 4/18 and 8/28, and we reduce them both to their lowest terms, 4 and 18 share a factor of 2, so that's going to be 2/9, and 8 and 28 share a factor of 4, and that's going to be 2/7. So here we do not have a true proportion. This is a false proportion. They are not equal to one another. The second method is probably the better way to figure out all types of proportions, whether they're true or false. It's very straightforward, and it's a cross multiplication or cross products. So what you're going to do is you're going to cross multiply, and it doesn't matter if you look upwards or downwards. As long as you stay consistent, you're going to be multiplying diagonally, just like what we would do when we would cross reduce fractions. So I'm going to multiply 5 times 4, that equals 20, and 10 times 2 also equals 20. So because the cross products are equal, that means the entire proportion is equal. 2 is to 5 as 4 is to 10. This is a true proportion. For the do together, we're going to use either method to check to see whether the proportion is true or not. I think it's simple now that we have calculators to go ahead and use the cross multiplication method. So when I multiply 20 times 12, I get 240. And 15 times 16 is also 240. So this is a true proportion. We can use an equal sign between these two ratios. For number 2, we have 7 is to 9 as 30 is to 45. This time, if we cross multiply, 9 times 30 is 270, and 45 times 7 is 315. So we can see that this is a false proportion. And the way we can indicate that is by using an equal sign with a slash through it. So 7 is to 9 is not as 30 is to 45. Fractions and decimals work the same way. We can cross multiply, and you can go in any order you like, top to bottom or bottom up to the top. I usually go up to the top. So 0.6 times 2 is 1.2, and 0.8 times 1.5 is also 1.2. So we have a true proportion here. These are equal. For number 4, we need to go back to our fraction rules. We're going to be multiplying 6 times 3 2/3. So we're going to use our C method. So this will be 6 over 1 times 11 over 3. And then we can cross reduce and multiply. 2 times 11 is 22 over 1, which is just 22. So I'm going to put the 22 above, and then I'm going to try my next one. I'm going to do 10 over 1 times 2 1/5, and I'll use my C method. That will be 11 over 5, and I can cross reduce. I'm going to divide by 5 and divide by 5. And 2 times 11 is also equal to 22. So even though they may not look proportionate, these two ratios are proportionate. This is a true proportion. 2 1/5 is to 6, as 3 2/3 is to 10. For the exercise, you can determine if the proportions are true or false. If they are true, you will write an equal sign. If they are false, you will write an equal sign and a slash through it. Remember, you can use either method, either reducing to lowest terms or using cross products. Cross products work particularly well with challenging fractions, with decimals especially, and even with regular proper or improper fractions, the cross multiplying can work quite quickly.